everyone. Thank you for coming to this session for OpenSDS. So I'm Lawrence Lai from Huawei, Business Development for Storage. Today I'm going to partner with Rakesh Jain from IBM. So I will spend first few minutes explaining what OpenSDS is and what it's about and what we're trying to do. And then I'll invite Rakesh coming up stage to explain more detail on the technical side. Before I talk about OpenSDS, I want to explain, just try to, explain some problem. Oh, sorry. Some of the challenges we're facing today regarding storage. What we see is the storage management is very fragmented. As more and more data being generated, stored in the storage systems, many vendors, they have storage devices from many vendors, and each of these storage systems have different software to manage data, and also to meet the business requirement, they also have to support various application framework and compute framework. That's another challenge for them. And so from vendor point of view, from developer point of view, from end user point of view, there are many challenges all through the different layers. For example, all the way from driver all the way to application layer. There are many questions about how you connect the storage to framework, how you provisioning, and from controller level, how to use different framework, and support various third-party IT software, and how to do integration. And so many different devices, whether this driver work for my existing system or not. That's also one of the challenges a lot of end users are facing today. So further, a little bit more on the some of the pain they're encountering for enterprise end users. Because they have so many different storage systems, they have to manage it with different software. They would love to have a common solution, be able to manage all the resources more efficiently. For developers, most of developers, they don't really want to deal with the complexity of various storage systems. They just want a simple way to be able to access and consume storage. So they would love to have standard APIs to be able to, abstract all these complexities, be able to, use the storage much more easily. From vendor point of views, they want to be able to sell into, enable their end users to use a storage system in an environment that many other, storage systems already exist, and they want to make sure their storage system work with other vendors' solutions. So OpenSDS basically is established to try to solve this storage integration challenges we're facing. It is an open source project and the Linux Foundation, and try to solve these integrate challenges and make sure the system end user have work with various storage system, also application frameworks upstream. And so the existing companies involved in this are traditional storage vendors, also lots of end users who are actually facing these challenges daily. So they're interested to get involved to understand, try to solve the issue. Also, we're working closely with other upstream application framework like cloud natives, OpenStack, as well as traditional enterprise software vendors. In terms of goal mission, So we want to be able to use a more simplified storage interface and make sure we have a storage controller architecture that's scalable and with standard open APIs. And be able to serve the application services related to the storage service. And so we want to we established a project team and a work group. We wanted to develop open source core-based components, APIs, and based on those to build a SDS solution. And we intend to grow the community and make sure we have values for end users, developers, and other open source community. And we try to encouraging collaborations even among competitors, storage vendors, users, and body, other standard bodies. We think this is a challenge that everyone's facing. By doing this, will benefit everyone. So our goal is to continue to grow a community to be able to get accepted in the industry in a broad way. So in the future, hopefully the vendor will just implement more vendor will implement this the solution based on OpenSDS. So just looking back historically a little bit, it's actually a pretty relatively new project, and So in March last year, and a few of storage vendors kind of met together and talk about, the challenge we're facing, and then we proposed to Linux Foundation in September last year, and so in a few months, and formally actually the project's launched with Hitachi, Huawei, Fujitsu, WD, and a few others. In December last year, EMC Dell announced they will participate in this OpenSDS project. And last year, early this year, we demoed the Kubernetes integration based on OpenSDS in Berlin, Cloud Native Con. So things are going well. We see, we talk to more companies are involved. Recently, IBM is involved, also NTT Communication and Yahoo Japan is another end user. Vodafone is another end user also involved in this. So again, we think that OpenSDS, the value that will bring to end users are, allow them to transform their existing, storage system from traditional enterprise on-premise to a platform they can run the cloud-native application much more easily by leveraging OpenSDS. And with OpenSDS, they can virtualize all these storage resources, be able to utilize storage resources much more efficiently. It doesn't matter where this storage solution come from which vendor. And that also help them to prevent a single vendor locked in, and make their integration much more easy. Once the OpenSDS is being supported all the systems. Value proposition for developers, it will have standard APIs, so they can access the storage much more easily and without had to learn about how to configure, integrate with the storage system from different vendors. And so they all have to do is develop once, and it should work everywhere. And so they can focus all the efforts on develop application instead of try to integrate with different storage systems. For storage vendors, this is the reason we started this, because it make our life easier, because it allows us to integrate with vendors end users existing system much more easily, and so allow them so we can accelerate the development cycles, and also leverage the OpenSDS community, allow us to build business more quickly and expand more quickly, and then find new business opportunities. And so overall, we think it's a win-win situation for end users, for developer, and storage vendors. So initially, the project will be focused on controller. So there are many things we want to do, but we think controller is kind of essential. So the controller will have reference controller will have APIs, northbound, southbound. Southbound APIs will be able to support different storage systems, and also be able to support OpenStack, other cloud APIs. And southbound API, northbound API will be able to support Kubernetes, cloud native applications, OpenSDS, and also traditional enterprise software. Our vision is not we're going to start with controller, but it's not going to stop there. We're going to also hoping that in the future we can create some new projects that focusing on some enterprise functionality that a lot of end users care about, such as performance monitoring, migration, things like that. So with that, I will invite Rakesh to come up and talk more detail about the architecture of OpenSDS. Thank you.
Thanks, Larry. So before I go into the technical details, I just want to share how I got involved with this project here. So I actually work in IBM research, and as part of my job, I work with different parts of IBM. One of them is cloud, of course. Other is global technology services. So global technology services basically is one of the largest IT service provider in the world. And what they do, they have one division called strategic outsourcing. And what they do in there is that they would outsource the whole IT operations of the companies. So as part of that, basically what they have now is thousands of customers. Now what is happening here is that these customers actually decide what hardware they will use, right? So now we have a situation where there are multiple customers. Each customer, of course, has multiple different hardware. If we talk storage, they have EMC, Hitachi, IBM, everything. And the problem is that how do you manage all this? Not only that, what we found is that there was a huge problem in storage provisioning, in the sense it was taking a long time. Taking the customer requirements, converting them into storage characteristics, and then executing them. Maybe multiple reviews there, as well as approvals and all that. So that was the challenge I was trying to work through. And that's when I actually, in one of the conferences, I got to know about OpenSDS, and it's exactly the same problem they're trying to solve here. So I thought, yes, this is what I want to do as well, and that's how I got involved here. So you get the idea, we are trying to solve a problem of heterogeneity, as well as work with the frameworks on the upstream. All right, so in OpenSDS, what is happening today, we have a couple of projects going on, or you can call them sub-projects. One is the controller project, as Larry mentioned. The idea here is that we want to create a universal storage controller with, of course, scalable architecture and open standard APIs. That's the dream, that's the goal. The key here is that, well, let me take this otherwise. What we want to do here, basically, as you see here in this figure, of course, we will have support for both block and file as well as object. And we will do all the discovery, provisioning, and all that. One key aspect in OpenSDS is the orchestration. What you want to do, you create the storage, you create the volume and file set and whatnot. There are a lot of activities happen along with that, which people want to do, but most of the controllers today do not have that capability. So they do all these things outside of the tool. So that's something we want to include in that. So that's policy-based orchestration. Of course, we want to support the whole range of storage as much as we can support. And another important thing is the features which the storage devices provide. These are like enterprise class features. And when you abstract these things out at the top, sometimes they get suppressed. Sometimes you cannot use them. So our objective is to make sure that we are able to expose these features as well so that the clients can use that. So that's one project. That's the core of OpenSDS. Sure. Yeah, good question. When we started, sure. The question is, are you going to use the standard APIs existing, or you're going to create your own new APIs? When we started, our thinking was that we'll be creating new APIs. However, after various discussions, there is no clear answer yet. We might go with some existing, but we still are evaluating. Maybe we'll have to come up with our own, or maybe we'll propose some extensions to existing ones. So let's see how it goes. But yeah, good question. We are on it. Okay, so besides, and feel free to ask any questions if you have. Besides that controller project, the other project we have going on is this plugins project. This is mainly on the compute frameworks. So if you see here, whether it is cloud native, Kubernetes, or Docker, or whatnot, all the way up to VMware, OpenStack, and SAP or Oracle kind of thing. So the idea is that we will create these plugins for these frameworks so that these plugins basically will talk to the OpenSDS controller in a standard way. But whether you're using Kubernetes, whether you're using VMware, when you're dealing with storage, your view would be much, much similar. So you won't have to deal with, in different manner for different framework for the same storage. So that's basically the simplification of storage from the framework perspective. So, these two things actually make a core for us, actually, will give us some minimal viable product. And then, as Larry had shared, other slide, where we have a lot of other things to do. For example, we want to create a dashboard, which can also show a lot of things, as well as it will allow you to do the configurations. Now, in terms of how we started, basically, you have to have some goals. So these were the design goals we started with. The first one is, of course, universal storage control plane. That's what we have to offer. Other thing is, of course, we want to abstract out the storage management so that it is vendor agnostic. Whether you want to aggregate different similar storage into, one set of pools, discovery, as well as virtualization you can do there. We do want to support out-of-box cloud native for sure. So in terms of, even in terms of how it scales. That's a challenge today. And then the rule-based controls, which is the policy-based orchestration we are doing. So with these goals, we set up some requirements for ourselves, and that's pretty straightforward. That's give me a cluster-level view of the storage. That's one thing. Then the lifecycle management, and as little as client configuration as needed. So, with these things, basically, how it looks today is this. If you combine those two projects, basically, you have this plugins in the compute frameworks, which talk to the OpenSDS API, which actually talks to the controller, which does all the hard work there. And then you have the southbound drivers, you can call. We are trying to leverage as much as possible what OpenStack has done, Cinder and Manila. So hopefully, with that, actually, we have a lot to learn, because we have been engaged with Cinder for a while, and we have seen how so many vendors, how different they are for the same storage terminology. It means different to different vendors. So we're trying to, we have learned something there, and we are trying to leverage that as much as possible. But yeah, the main thing we bring in here is that policy-based controls, and then the enterprise class capability. And basically we want to support everything. So block file storage, and then all kinds of storage enterprise class features, including replication and quality of service and all that. To start with, yeah.
You have replication here for redundancy. Would you add the erasure coding also?
I'm sorry?
For redundancy, I see you have replication. Will you also add erasure coding?
Erasure coding, so yeah, the question is, you have replication, would you have erasure coding as well? Yes, that's the plan, definitely. We have started with block for now, and then as time goes, as things stabilize, we'll go into the file and object. Now, I want to share a few concepts and how we are actually thinking currently. So, usually how a request will be made for the storage. So a tenant basically would request the storage by selecting a storage profile. Now, what is storage profile basically is the one which contains details of the storage. Of course, it will have name. It will have, for example, it can have tier information. It can have replication information. It can have mirroring, local mirroring, things like that, as well as who can access what. So I will go into the details of that storage profile in a bit. But the idea here is that there will be multiple profiles. They will make up a storage service catalog. And out of this service catalog, the tenant will pick the storage profile. Or in certain cases, this storage profile will be picked automatically, depending on the use case. So with that profile selected, the request will go to the OpenSDS controller, which actually will understand what to do down level, and it will create the. In this case, it is for creating the volume. So this is the simple concept of storage profile and the service catalog. The other thing is this is pretty high level. Basically, it's pretty common that how are you going to have it in different regions, especially in the cloud kind of scenario, right? So we are hoping that there will be one controller per region, and then region is divided into zones, where you can have physical pool, virtual pool, the way usual setup basically. And then, of course, we will have something called consistency group, or now it's called storage group. Again, this terminology thing. But this is mainly for the replication of the consistent replication of the volumes. Now, let's talk about the storage profile we touched upon briefly. This is actually a very interesting area. We are right now discussing how we want to do this. One storage profile can contain, of course, which region or regions it would be applicable to, what protocols are supported, and then there are certain policies. For example, who has access to it? So that's the access control. There is another thing, like how much or what is the maximum capacity I want to allow when this particular profile is selected. I'll give you some example here, how it is done today or what we have seen in the field. So there are some scenarios where people want, the storage administrators want, that if the request is for, let's say, just pick a number, let's say if it is for 1 terabyte volume or volumes, I want it to go through the normal process and, wherever the best pool is available, create the storage and so on. However, if the request is more than 1 terabyte, I want it to go through an approval process. So there is a workflow in there. So that's one scenario. We have seen it a lot actually across accounts. It's probably not that applicable in cloud, but I'm sure in some sense it is there as well. So we are thinking on that aspect as well. The other is, of course, the security and protection. That's also quite heterogeneous across the devices, so we're trying to standardize that as well. Same with replication, but replication actually, people want to do different kind of things. You do sync replication or async replication, that's fine. But I want to actually create snapshot at the target every day or every 10 hours, or I want to delete old snapshots every week, whatever, right? So things like that, that's something also which is quite common. And then I'm not talking about journal volumes and all that, but that's also is there. Another thing is the life cycle. And life cycle has many meanings, but let me give you one example that what you want to do after you detach the volume. You want to delete it right away, you want to keep it for some time, or even before you detach. There are scenarios people actually make mistakes, right? So some administrators want to set the policy that detach only if there is no I/O happening, meaning that volume has been unmounted, has no I/O happening for X amount of time. That's one example. Or similar thing with delete. Actually, delete it after, actually, if the request is for deletion of the volume, actually do not delete it, but keep it for 48 hours, then delete it. Because, again, people make mistakes. And that's quite common and it's quite costly. So this kind of things we are trying to solve with this, at least have the ability for the administrators to set these things. And then, of course, sharing and the optimization, which is basically whether you want to create thin volumes or compressed volumes. I'll give you one example. This is from a healthcare company. What they are doing actually is that they have this kind of scenario that if my volume if the request for the volume is less than 500 gig, for example, create a thin volume, all right? But if the request is for greater than 500 gig, create a compressed volume. Now, this kind of policies we should be able to support. I think the simpler ones are very common, like the pool size. If pool is 80% full, don't allocate in that. Or if it is thin one, if it is overutilized by 125% or so, then don't use that one. So those are standard ones. Definitely will take care of those. Besides this, of course, we'll have support for custom because not everything will be covered by this thing. Now the other aspect is the workload profile or the performance profile. So how much IOPS, throughput, data transfer rate, and all those things, whether it is sequential read or random read and things like that. Along these lines, we are also thinking, because these are all storage terminologies which the application side do not understand that well. So we are also thinking about having something called application profiles. It's still under discussion. But as Larry mentioned, that we have active participation from the user community, right? So they bring us this kind of things that, this is all great, but all I want is that give me storage for my MySQL database, a volume for the log, a volume for the data, things like that, right? And maybe some other characteristics like, I want to protect it this way or that way. So we are still trying to figure out how best to do it. So there's kind of possibility of an application profile to go with the storage profile. Any questions so far? Good. Okay, so this is basically another way of looking at it. Basically, we'll have the plugin project and then the API going through the controller and going to the backend. I do want to mention that we are actually working quite closely with Kubernetes on their CSI specifications, trying to understand that and where we are with that and how we can implement that. But besides that, actually, we want to make sure we can still do policy-based storage control for the cloud native deployments. So we actually have, of course, not CSI yet, but we have one implementation of storage class provider. So there is a OpenSDS provider in Kubernetes, if you know the storage class concept in Kubernetes. So we have one implementation where how we can use OpenSDS with Kubernetes in that sense. But again, this is a very dynamic field with a lot of things happening and changing, and we are trying to keep up with that. Of course, we are working with OpenSDS, OpenStack. As I mentioned, there is a lot to learn from there, as well as much as we can utilize what is Cinder and Manila and Swift have done. So we'll continue with that. We do add value there through the orchestration. I do want to mention that we do have one implementation with OpenStack, and that is mostly on the orchestration side. So we have created a OpenSDS heat resource kind of thing, which goes with OpenStack heat. So that's one aspect. Again, excuse me. We do not have a release yet, so as not even alpha release, and we are trying to get to the alpha release pretty soon. But the idea here is that we are experimenting in a lot of different ways, a lot of different things, and hopefully once we settle on certain end-to-end scenario, we will have the alpha release coming out pretty soon. So that's OpenStack. Now, I do want to mention one thing about the end user community, which is involved with OpenSDS. One of our partners there is Yahoo Japan, and these slides are, by the way, from Yahoo Japan. They have joined the OpenSDS community from the end user perspective. And as you see, they are one of the largest internet company in Japan, 100 plus services, earning 62 billion page views per month. So it's pretty impressive. They have 6 data centers, 100,000 plus servers, 50 petabyte of storage, 50 plus OpenStack clusters, 50,000 instances, and of course the next generation. They have both Kubernetes and Cloud Foundry there with OpenStack. So, of course, the complexity, right? You have traditional storage, you have HDFS for Hadoop workload, you have Cinder, Swift, Manila, everything there, and then persistent storage for the Kubernetes kind of things. So how do you manage all this? So this is their challenge today. And once they learned about OpenSDS, basically, they were happy to join us. According to them, we need open, fair, and long-term software project for storage management to reduce complexity and improve convenience. So that's the state we are in. We have, as Larry had mentioned, we have some other end users who also joined, like Entity and Vodafone, I believe. Yeah. So yeah, that's pretty much what we have as of the status of OpenSDS project. We would be very happy if you join the project in whatever capacity you can and contribute your expertise there. I do have some demo. Actually, I wanted to do a demo on this setup, basically with Huawei Dorado storage system, and another one with IBM XIV. But of course, as of this morning, it wasn't ready. So what we have is different demo, and this is with Kubernetes. What we are doing there is that, as I mentioned, so with Kubernetes, we have one provider implementation, which is a standard way of doing storage management as of today. Other thing we are working on, the CSI. But what we have found in all those cases is that you cannot actually present some other storage features you want to present at the Kubernetes cluster level. So another experiment we did, and that is with Service Broker. Service Broker is a concept. Basically, you provide service within the Kubernetes cluster. So Cloud Foundry uses it, and Kubernetes has adopted it. It's an incubator project, and it is supposed to be implemented in the coming releases of Kubernetes. So what basically it is that it provides the service to the cluster. So what we have done actually is basically we have created a OpenSDS service broker, which provides storage services to the cluster. So that's the idea. Let's see if I can. I have a recording of the demo. This is, by the way, all on the GitHub repository. Let me first give you the GitHub address. Yeah, so this is the OpenSDS.io. If you go there, you can have all the details, and from there you can go to the even the demo and everything. The code for the demo is all there from there. So I have this recording of this demo. This is on GitHub as well. Let me first give you what is needed for service catalog. So in Kubernetes as of today, given that it is not integrated fully in the Kubernetes ecosystem, to create a service catalog or a service, basically, to provide a service, you have to install your service broker, of course. Then you have to Let me actually run it and then I will show you accordingly. Okay, yeah, this is little off way. So this particular thing actually right now, what we have in Kubernetes cluster or in this demo is that we have OpenSDS controller as a container. We have OpenSDS broker, of course, as a container. And in the backend, we are using Ceph for the storage. All right. So this particular screen you see here, basically we are showing that what are the profiles or storage profiles available on OpenSDS. Right, so that is a REST URL for getting the profiles. So as you see here, there is a default policy plan. For the people in back, I think it would be difficult to see, but hopefully you will be still able to follow through. So this is basically one profile we have. Okay. Now, I'll stop here. There are a few things you have to do when you have to create the broker. So this is the first step here is that OpenSDS broker has been created here in Kubernetes cluster, and it will list the broker and the service classes. Service class basically is the service you want to use, all right? So that's what you would be creating there. The second step you would be doing is creating the OpenSDS service instance. What it does is, at this point, based on whatever is in the service, it will actually create the volume, and then at the third step, which is the binding, this volume will be available within the Kubernetes cluster. As well as during the binding, what happens is that there are basically some secret generated by the broker, and that secret is shared by the Kubernetes cluster. All right, so we'll do these 3 steps, and I'm actually running short on time, so I'll try to run through as well as explain if possible. Okay, so that's the broker. And we'll just list it, what the broker and what the service class is. Okay. Here it would show that for that service class, we have default policy plan. So the idea here is that we are exposing this storage profile through this service within Kubernetes cluster, which is not possible in doing the other ways. So that's why this implementation. So now we have created the instance. So once you create the instance, it goes and creates the volume. So this is the OpenSDS controller side, which shows that the volume is created now. This one actually shows that for the safe, then that image was created, which is the block storage volume image. And this is the instance which got created. We just listed that. And now we will do the binding. Right. So when you do the binding, basically that's when the secrets are shared with Kubernetes, and then if you see there's the secret. Of course, it doesn't list it. It doesn't show the value. But the idea here is that what we are sharing here is the image ID of the image, volume image, which got generated in the Ceph, so that you can use it in your pod definition in Kubernetes. So basically, that's how you bind your pod, your Kubernetes pod, to the volume. So this is basically listing the safe images. So the key thing here is that with this mechanism, we are able to create volumes by specifying the policies or the storage profiles. So in this example, we are using the WordPress demo, and for WordPress, we are using this RBD volume, if you see there, and then this is where we are pasting the generated volume image ID, which we just created. All right, so that's created. Now we can just check the status of it. So what's the advantage here? What we have done basically is basically given a volume to the Kubernetes cluster and to this pod. Now, as this pod scales up, scales across the nodes, then we have what will happen in that case, right? So it is the same YAML file for WordPress, right? The volume is going to be available on all the nodes, right? So basically, this is a cluster scenario where you have multiple servers, in this case, multiple pods, using the same volume across the nodes. So that's basically what we are trying to achieve with this kind of. So those two things, basically, one is able to use the storage profile, and another is be able to scale accordingly. This is an example. Basically, you can persist the data. And I'm actually out of time. I got 2 warnings. So I will stop here. This is basically, just completing that you are able to write the data in the WordPress you just created. Any questions we can go into? Yeah?
So this looks like it's primarily a provisioning tool?
Currently, it is provisioning, yes.
Is your goal for the future that it would also be access as well, or is it just going to be provisioning and management?
Okay, so the question was whether it is just a provisioning tool or not. So currently, it is provisioning tool. But in future, are you going to use it for access? That's what you're saying?
Right. Are you going to try to abstract out the underlying software and manage that yourselves?
Definitely. The whole idea is whether you want to abstract it out or not. No, whole idea is to abstract out as much as possible. The reason in this demo particularly, what we did here is a little different because Kubernetes already has this concept of using RBD or this or that for the volume. So we are using that as is. The only thing we have done is we have separately created the volume through the storage broker, service broker. Any other questions? Yeah.
This is mainly driven by IBM and Huawei today?
Is it mainly driven by IBM and Huawei? Actually, you want to answer? Sure.
Yeah, so as I mentioned earlier, like the project just started. So right now we also have a storage vendor like Hitachi is involved in this, and we're also talking to other storage vendors like EMC and NetApp and HPE, all these guys. We can we'll have more announcement when they officially participate.
Yeah, there is quite a bit of unofficial participation right now. It's the official way takes time, so that's what is taking time right now. Okay, nothing else, then I guess we are done. Thank you very much for coming, and hopefully you can participate with the project and help us make it successful. Thank you.
Yeah, thank you very much.